So, OpenAI just did something pretty major. They've released a whole new family of powerful open-weight AI models. But this isn't just your standard model drop. This is really a story about this incredible gift to the world and the guardrails you need to keep it safe. All right, let's dive right in.
I mean, this is the question in AI right now, isn't it? What happens when one of the top labs, a lab famous for its super powerful closed models, decides to just open up its secrets? What does that mean for developers, for safety, for the future of AI, really? That's exactly what we're going to break down here.
Okay, so first things first, what did OpenAI actually put out there? Let's get right to it.
All right, so they've dropped two new text-only models. You've got the GPT OSS 120B, that's the 120 billion parameter heavyweight, right? Built for really tough, complex reasoning. And then you have its smaller sibling, the GPT OSS 20B. It's a much more nimble 20 billion parameter model, super efficient. Basically, two different tools for two different jobs, and now they're out there for anyone to grab and build with.
So let's pop the hood and see what's inside. Both of these models are running on something called a mixture of experts architecture, or MOE for short. Now, the best way to think about this is like having a team of specialized consultants. Instead of one giant brain trying to figure everything out, the AI is smart enough to route your problem to the exact right expert for that specific job. It's way more efficient. Plus, they're released under the super permissive Apache 2.0 license. They're built for reasoning and tool use, and get this, they have this really cool special skill called variable effort reasoning. We'll get to what that means in a bit.
Okay, that all sounds great on paper, but the real question is, how do they actually perform? Well, OpenAI put them to the test, and honestly, the results are pretty surprising.
All right, check this out. On general reasoning, and we're not talking simple stuff here. We're talking PhD-level science questions, super hard math problems. These GPTs models are right there in the mix from day one. You can see the 120B model. That's the one in orange. It's going toe-to-toe with OpenAI's own closed models like O4 Mini. It's even beating it in some cases. For an open-weight model, that is absolutely incredible performance.
And it's not just reasoning. For developers, this is huge. When it comes to coding and using tools, these models really shine. Just look at the benchmarks. They're getting seriously close to the performance of the absolute top-tier models that are out there. This makes them ridiculously useful for building actual real-world apps.
Okay, so remember when I mentioned that variable effort reasoning feature? Well, this is what it actually looks like. It's wild. This chart basically shows that you can tell the model how hard to think about a problem. If you give it more thinking time, which here is just more chain of thought tokens, its accuracy on really tough problems just skyrockets. So you get a choice. It's this awesome trade-off between getting a quick answer or a much more accurate, deeply thought out one.
But you know what they say, with great power comes great responsibility. And this is the moment where the story really pivots. We're moving away from just how powerful these things are to the absolutely critical question of safety.
So before they could even think about releasing these, OpenAI had to test them against all the standard risks, the usual challenges that every powerful AI model has to deal with.
Right, so one of the biggest and most common risks is something called a jailbreak. It's pretty simple, really. It's just when someone tries to trick the AI to get around its safety rules, so it'll generate stuff it's not supposed to, like harmful instructions. It's this constant cat and mouse game in the world of AI safety.
So, how did GPT-OSS do against these jailbreaks? Well, the data shows they're actually right on par with existing closed models like O4 Mini. These numbers you're seeing, they basically just show how often the model said, "Nope, I'm not doing that," when someone tried to jailbreak it. The scores are really high, which is great, shows strong resistance. But of course, no model's ever going to be perfect. What this does is establish a baseline. It tells us they're just as robust as other models in their league against these kinds of attacks.
But here's where it gets really interesting. OpenAI went way, way further. They didn't stop with the standard risks. No, they moved on to testing for the extreme stuff, the catastrophic dangers. We're talking about the kind of scenarios that literally keep AI safety researchers up at night.
And this is maybe one of the most serious questions you can ever ask about a new AI model. Could someone, a bad actor, use this thing to get better at creating a biological weapon?
Well, after a whole lot of testing, the answer was a clear and resounding no. OpenAI's conclusion, and they state this directly in their paper, is that releasing GPT-OS is, well, it's unlikely to significantly help anyone trying to create bioweapons. The model is powerful, for sure, but it just doesn't cross that critical, dangerous threshold.
Okay, what about cyber warfare? For this, they didn't just, ask the model some hypothetical questions. No way. They put it inside what's called a cyber range. Think of it as a super realistic, simulated corporate network. And they basically told it, okay, go carry out a real cyber attack from start to finish.
And we're not talking about simple stuff here. The model had to go through these complex, multi-step operations that are designed to look just like real-world hacking campaigns. They even tried giving the model hints along the way, just to see if it can get the job done with a little help.
So what was the result? 0. A big, fat 0%. The model could not complete a single one of the cyber attacks. Not a single one, even with hints. It failed every single time. And that's the key takeaway here. At its current level, this model cannot be weaponized for autonomous cyber attacks, period.
And the last big, scary risk they tested for was AI self-improvement. The sci-fi idea that an AI could start making itself smarter and smarter really fast. So they tested it. Can it solve real software engineering problems? Can it do the same work as OpenAI's own engineers? Can it reproduce brand new AI research? And the finding was nope. It showed no dangerous ability here either. It just couldn't improve itself in any meaningful way beyond what we've already seen from other models.
So let's pull all of this together. What's the big picture? Why does this release actually matter so much for all of us?
And this is really important. This wasn't just OpenAI marking their own homework. An external safety advisory group reviewed all of this testing. And their conclusion? It completely backs up what OpenAI found. They said that even if someone tried their absolute hardest to fine-tune this model for bad stuff, it still didn't reach that high capability level for any of these catastrophic risks.
So if you take away anything from this, it should be these 3 things. First, OpenAI has given the open source community a really powerful gift. Second, that gift came wrapped in some serious guardrails. They did all this frontier-level safety testing before it ever saw the light of day. And third, the final verdict is that, yeah, these models are powerful, but they don't seem to have those truly dangerous capabilities that could lead to catastrophic misuse.
When you zoom out, this release isn't just about 2 new models. It's about setting a whole new standard. It's a new precedent for what responsible open sourcing of powerful AI can look like, pairing incredible capability with really deep, transparent safety work. And that leaves us all with one final massive question. How is the rest of the industry going to respond?